Hey guys, welcome back to my channel. In this video, we'll be solving a resultant of force system problem, which is part of the FE exam review series that I've started. So let's get right into it. The problem reads as follows. Four forces act as shown below. The magnitude of the resultant of the four forces is equivalent to option A, 342, option B 120, option C 255, and option D 80. All right, so the very first step will be to draw our table for each of the forces component. And as you can see, this is just a force system in 2D, so we only gonna have to worry about the X and Y axis. So let's draw our table. X for all the X components of each of our forces, and then Fy for all the Y components. So you can start with whatever force you wish to choose. So I'll start with 500 pounds. So I'm gonna draw on the side here 500 pounds and change color here. So this is our X component and our Y component. And in order to find the X component, we're gonna look at this angle here. Look, the angle was given in the form of opposite side value as well as the adjacent side value. So as you can recognize right off the bat, this is a 3 4 5 triangle, meaning that the hypotenuse will be equal to 5. If you want to double check just to make sure that your hypotenuse is correct, you might want to use the Pythagorean theorem, which states a squared is equal to b squared plus c squared, a squared being the hypotenuse of the triangle. So a will be equal to square root of b squared plus c squared, and as we can see here, we have b for 3, so 3 squared plus c 4 squared, and if you plug that into the calculator, the answer will be square root of 25, which is equal to 5. So now that we've calculated our hypotenuse, let's get back to identifying or calculating the X and Y components of this force. So we have 3, 4, 5. So the component of the force will be equal to the magnitude of the force, 500 pounds, times the value that lays on the x-axis, or the value that is parallel to the x-axis, which is 4, over the hypotenuse, which is 5. And one of the things that we'll have to keep in mind is the sign. As we can see, for this specific force, all the arrows are pointing toward the positive side. The x component is facing toward the positive x-axis, and the y component is also pointing toward the positive y-axis. So we know that these two values will be positive. So getting back to the problem, I did not mean to erase that. For the y component, we'll have 500 times the opposite side, which is 3, over the hypotenuse, which is 5. So I'm gonna get rid of that. All right. If when we plug in these values on the calculator, that gives us 400, and for the y component, that gives us 300 pounds. Okay, moving on to next force. Let's do the 65 pound. Same thing is happening here. We have a 5, 12, 13 triangle. So right off the bat, we know that the hypotenuse will be equal to 13. But once again, you can, if you want to double check your value, if you want to make sure of whatever you have, you can always use the Pythagorean theorem. So this one will be equal to, we're just going to break it down the same way we did for the 500 pounds for force. So right here, 65 pounds. We have the 5 here, and then 12 and 13 here. So in order to find the x component, same thing, we're gonna use the 65 times the adjacent side, since it's parallel to the x-axis, over 13 the hypotenuse. And for the y component of that force, it will be 65 times the opposite side, 12, over the hypotenuse, 13. And the answer, and once again, we're gonna double check our signs, and as we can see here, the x component is pointing towards the negative side of the x-axis, so meaning that our x component will be negative. However, the y component is oriented towards the positive y-axis. As a result, we know that that'll be positive. So plugging this number into the calculator gives us negative 25 and 60 on this side. Okay, so moving on to the 50-pound force. Let's get rid of that. Draw a vector, 50 pounds. We have the y component. This is our x component, x, and we have an angle of 60 degrees. As we can see here, the x component will be the opposite, so the sign of so it'll be the magnitude of the force times the sine of 60, and the y component will be the magnitude of the force times cosine of 60 degrees. Okay, last thing we check once again is the sine, and as we can see here, both components are facing the negative sides of each axis. The as both will be negative. Okay, so plugging this number in the calculator yields negative 43.3 and negative 25. Okay, last force our system is the 250 pounds, and as we can see right off the bat, the force does not have an x component, so that will be 0 here, and we have a negative force on the y component. Okay, so now that we've broken down all our forces, we're gonna sum them up. 131.7 and 60 minus 25 minus 250, and we get 85 on this side. Okay, now the step will be to find the resultant of the four forces. Using the fr is equal to square root of fx squared plus fy squared. And once again, if you don't have this memorized, you can search for resultant force in the FE reference handbook, and you should be able to locate your equation. But this is a pretty simple equation, so it's easy to memorize. We plug in our values in the equation to find our resultant force. 5 squared, and plugging the numbers into our calculator gives us 331.7 squared plus 85 squared. Square root of that gives us 342.41 pounds, which is equivalent to 342 pounds. And looking back at our proposed answers, it'll be option A.